parallel lines, the key concept with parallel lines is that they have the same gradient. If two lines are parallel, then they're going to have the same gradient. Now, questions could be modeled differently. The first one, they could give you the equation of a line. The important thing is always ensure that the equation of a line is always in the general form. Y is equal to mx plus c. The reason why I need to do this is that's the only way you'll be able to determine what the gradient is. It must be written in this general form for you to determine what the gradient is, right? So, for example, if I had 4y is equal to 16x minus 12, this is not in this form. I need to move this from here. And that will mean that I have to divide everything on this side here by 4. So that I will get 4x minus 3. This is the form that we need. Only at that point could we determine that the gradient is 4. Right? So 16, we can't say 16 is the gradient here because this is not in the form y is equal to mx plus c. And this is a very important thing to understand when you're doing parallel lines, right? Because with parallel lines, all we need to do is to take the gradient from the line given. So here we're given the equation y is equal to 4x minus 3. This here is the gradient. If we have a line that is parallel to this line and passes through the point 0.5, and we want to find the equation of the parallel line, we will use m to be the same 4. They gave us the point 0.05. So that's supplying x1, y1 values. And then we will use our formula. So it's just like finding the equation of a line. You just need to know where you're getting your gradient and your point from. The formula is y minus y1 is equal to m into x minus x1. We know what we substitute in here in these places. Y1 is going to be 5. M is going to be 4. X is going to be 0. Put in the rest of stuff. So y minus 5 is equal to 4x. 4 by 0 will be 0. I'm moving this across the equal sign. I'll get y is equal to 4x plus 5. This is the equation of the parallel line. Right? Fairly simple. Let's talk about perpendicular lines now. Now, the key with perpendicular lines is that the gradients, the correct assumption or the correct thing is that the product of the gradients must always give you a -1. That's kind of difficult to remember. So what I tell students is that if this is the line that you're given, right, again, it must be in the form y is equal to mx plus c. The gradient of the perpendicular line will be the negative reciprocal, in other words, the inverse of the number. So, gradient. So this is easier understood with the example, right? If this is the line, the perpendicular, I'll use this to represent perpendicular gradient. You change the sign, it will be negative, and you flip the number a half. This is what the gradient, the perpendicular gradient will be. If I have another line, let's say this line is a line K, and I want a line perpendicular to this. We're going to change the sign. It was positive, it becomes negative, and we flip the number. So this Third, will you move the 3 on top, you put the 1 below, you get -3. Here's another example. Let's say we have a line y is equal to -2/3 x plus 15. The perpendicular gradient, we will change the sign, flip the number. Yeah? Change the sign, flip the number. So for the perpendicular gradient, change the sign, flip the number. Yeah? All right, so let's look at this example. We have, this is the equation here. So we given y is equal to 2x plus 1. We need to find the equation of the perpendicular line passing through 4, -2. So check my solution. 1, we need to find the perpendicular gradient. How are we doing that? Change the sign. So it becomes negative and flip the number, a half. Right? So we're going to use m to be -1/2, and they gave us the point. The point is 4, -2, and the point 4, -2. And this is going to be my x1, my y1. Formula for equation of a line remains the same. The only thing changed is the way in which we find the gradient. And we substitute in here. Here, here, here. Right? So y1 is -2. Put it in our bracket if it's negative. -1/2. X minus x1 is 4. Y minus. So minus by minus giving us a plus here. -1/2 by x will give us -1/2 x. And negative by negative is a positive. And half of 4 is 2. Right? Next, we move in this over here. You get -1/2 x plus 2, that is 2, minus 2. So y is equal to -1/2 x. And 2 plus 2 is 0. So y is equal to -1/2 x. This is the equation of our perpendicular line. So once we know how to find the equation of a line, finding the equation of parallel and perpendicular lines all has to do with establishing what the gradient is. Parallel lines have the same gradient. Perpendicular lines, we change the sign and flip the gradient. And for both of them, we need a point to supply x1 and y1 figures. Yeah? Let's bring all of this together. So let's look at a full question. We have the line AB passes through the points A, 2, 3 and B, 6, 7. This is providing us with x1, y1 values and x2, y2 values, right? So let's write our points. So x1, y1, x2, y2. 1. They want us to find the gradient. Put a formula, m is equal to y2 minus y1 over x2 minus x1. That's why we wrote these points on top. So we look above, y2 is 7, y1 is 3. We look below, x2 is 6, x1 is 2. M is equal to 4, over 2. M is equal to 2. Part 2, the part 2 here, they want the equation of the line AB. So we have using M to be 2, and we could use the points 2, 3 to provide more with more x1, y1 values. A formula for the equation of a line, y minus y1 is equal to m into x minus x1. We plug in those values here. M is going to be 2, x1 is 2, y1 is 3. We're working it out. 2x, 2 by the sigma negative 4. Y is equal to 2x minus 4 plus 3. Y is equal to 2x minus 1. That's the equation of the line AB. A second point passes through. The second line is parallel to AB and passes through AB. Parallel lines have same gradient. The gradient we're using is going to be 2. The point we're going to use is 1 minus 2. That's going to supply more with x1, y1. Equation, parallel line. Put a formula. Y minus, remember brackets for negative numbers. So we get plus 2, 2x minus 2. Y is equal to 2x minus 2. Now carry this across, this becomes minus 2 as well. So we get 2x minus 4. Part 4 wants the midpoint. Need to make sure we remember our points 2, 3, and 6, 7. So we have the points 2, 3, and 6, 7. That's supplying us with x1, y1 values, x2, y2 values. Put your formula. X1 is 2, x2 is 6, 3, and 7. But this is our point. So you get 8 over 2, 10 over 2. 4, 5. This is to find the gradient of the perpendicular bisector AB. Now, the line or the equation of the line AB so y is equal to 2x minus 1. The gradient here is 2. The perpendicular gradient. Change the sign, flip the number. Right? That's our answer for the gradient of the perpendicular bisector. Now, part 6, when they ask for the perpendicular bisector, what do we use? So we need the perpendicular gradient and the points we will use is the midpoint. And that will supply my x1 and y1 values. So m is equal to -1/2, and our midpoint is 4, 5. Our formula for the equation of a line is y minus y1 is equal to m into x minus x1. Subbing values here, here, here. Right? So y1 is 5, m is -1/2, x1 is 4. I'll put in the rest of values. Y, x minus 7. Expand our brackets. Get -5 is equal to -1/2 x. And negative by negative will give us a positive. Half of 4 will give us 2. Next thing I'm going to do is move this 5 over here. It becomes +5. So we have -1/2 x plus 7. And this is the equation of our perpendicular bisector.